Assalamu alaikum. Hello everyone. Developing us today, technology lovers. Welcome to the biggest festival of GDG Algiers. I am Yusra, GDG co-organizer. Like every year, Devfest 2020 will have a bunch of different interesting talks. But before starting our talk for today, let me remind you of the agenda. After this talk, we will have a talk about how to keep your kids safe online by Abdelaziz Al-Hamadi. The next one will be how to run or running serverless app on GCP with Cloud Run by Abdel Fattah Sghiwar. The next one will be programming for kids workshop with Snai. Then we will have a talk about كيف تخذلين المجرم الإلكتروني عن طريق الهندسة الاجتماعية العكسية with دكتورة جليلة. Then talk about the world smarter using of IoT by Ben Hamida Fatima, and ending with gender equality in tech session. Starting our first talk with Mr. Ayoub Benaissa, who will present a talk about privacy in artificial intelligence, which is a vastly growing field. Mr. Ayoub is a computer science engineer from the Higher National School of Computer Science, AZSBA. He is a Homomorphic Encryption team leader at OpenMined. So welcome, Mr. Ayoub. We are so glad to have you in our event. So thank you for accepting our invitation.
Thank you for having me. Assalamu alaikum, everyone. I think I should start with sharing my screen. So yeah, here's my screen.
Well, I think.
Okay, great. Welcome to the Privacy Preserving Machine Learning talk. I'm really happy to be here, and thanks for GTG Algiers for organizing such a great event and the invitation. I've been working in privacy preserving machine learning for almost a year, mainly using homomorphic encryption. But today I'm going to talk more about privacy preserving machine learning in general without focusing much on any technical details. So we first will look at what privacy-preserving machine learning is and what are the motivation for using such techniques. Next, we'll look at two usual use cases of machine learning, namely training and evaluation, and see how privacy-preserving technologies can help in working with machine learning. And we conclude with some directions and next steps, or where to go next. Privacy preserving technologies are here only to assist machine learning. So they are part of the machine learning process. These technologies aren't going to replace the final goal of machine learning. We are still going to want to build classifier of cats versus dogs, but what we doesn't want is to have access to the training data or the input data during the inference process, or maybe sometimes protecting the model itself. If, for example, I'm building a sentiment classifier based on person's face, I will need to have enough data to train my model. But if people care about their privacy and will never give me the pictures of their faces, then I will never be able to do so. And privacy-preserving machine learning will integrate the process of training this machine learning model to make sure that people can give me access to train on their data without being able to see it. So I will be training on data that I don't own and I will never be able to see. And one of the main motivator is users' awareness. That's because when people know their rights around privacy, they will be more exigent towards product developers. And as product developer, you may have a lot of features to implement, and you actually prioritize them according or depending on some key variables. If you see a lot of users demanding that, it's already a sign that you should really think about that. Otherwise, you would prioritize more functionality to your product, think about user experience and things like that. Also, companies nowadays doesn't want to be in the news with the title like company X knows you more than you know yourself. And because it may make a really big noise among users and they will end up switching to an alternative product. Also, regulations also play a big role in pushing companies to implement privacy-preserving technologies. As more strict regulations are applied, then I guess there will be more to come. We have already seen like big companies putting a big amount of money for not being compliant. GDPR fines, for example, can go up to 20 million euros or 4% of the annual revenue of the company, which can be much more for big companies. So better be compliant and invest this money in research to develop privacy-preserving techniques. And as product developer, you may ask yourself, what are the benefits? What am I gonna win from this, apart from being compliant and winning the hearts of my users? And like, of course, not losing 20 million euro is already a win, but can I get something more out of it? And fortunately, the answer is yes, because even if there was no regulations, companies will be hesitant to share their collected data from different local sources with other companies, with a goal to train a more generalized or better machine learning model. So every company will want to keep her intellectual property, but with these privacy-preserving techniques, even concurrent companies can start collaborating on data, making single entity access a big amount of data from diverse sources. And machine learning practitioners know how much added value this is. That data is one of the main fuel for machine learning, and struggling to get access to good quality data is an annoying blocker for advancing a machine learning project. So to recap, PPML, privacy-preserving machine learning, is just integrating privacy-preserving techniques into the usual machine learning process that we all know. And this will help us build more collaboration around data, but of course will remain private. And to see how privacy-preserving techniques can be integrated into the machine learning process, we will take a look at some machine learning use cases. We will start with the training use case. The usual training use case that we know. And so we'll get back to our previous example of training a sentiment classifier based on a person's face. Here we might have an already trained model, and we want to make it better for our user-specific data, or we are training it from scratch. So in both cases, we will need to use our users' data. And the simplest solution would be to just gather all the data in a central server where the training will take place. However, this is a huge deal for data privacy, as every client needs to upload his entire data in plain form. And it's not just a matter of trust. We can actually trust the server owner for not looking at the pictures we are sending him, but data leaks may happen at the server level, for example. So what can we do about it? We still want to be able to train this model on the available distributed data, but clients may also don't want to help us unless we are privacy preserving. And now, instead of bringing the data to the model, we'll bring the model to the data. And this technique is called federated learning. What happens during the training process is that the server starts by sending the initial model in blue to the clients. Then every client will train the model on his local data and send it back to the server. And finally, the server will aggregate these models by computing the mean of the weights, for example. And as you can see, the left client have sent a green model. That's because he has trained his model on this green data. This just means that this model was trained specifically on this specific data. And the final aggregated model is a combination of all the client's color, which means he kind of learned about all the distributed data by doing the aggregation. And now this final model can be used as the initial model for the next federated learning iteration. So this process can be repeated again and again over different clients in order to learn from different data sets without really seeing them. So now our data stay on device, but what about these updates we are sending back to the server? Because as we have seen, this green model just trained on this specific green data that is private. So can it be holding something that actually shouldn't leave the device? So if these updates will be just memorizing all the data, then it would be just like sending the data. To answer this question, we are going to look into two attacks aimed at machine learning models. Membership inference attacks aim at answering the question, was this data point part of the training data set? So in our example, we would take a person's face and want to know if the model used it for training. On the other hand, data reconstruction attacks aim at recovering some training inputs. In our example, it would mean recovering some pictures that were used during training. These attacks can be made in different settings. We talk about black box attacks that doesn't know anything about the model, but only have access to an API to query the model. So the information we can get from this is pairs of input-output that we should use to perform the attack. There is also the white box attacks that knows more about the model, like its architecture, its actual weights. And so we have more information in this setting, which will widen the range of attacks. And the federated learning process fall in this white box setting. The server knows the architecture and he gets the updates made on the user's data at the end. And previous works have shown that it's possible to perform these attacks in this federated learning setting. So even if the data doesn't leave the device, we still have other privacy threats that we need to deal with. So let's see two techniques that can help us go against this or defend against these attacks. As the server's goal is to build this final aggregated model, seeing the individual updates is not necessary. And a technique called secure aggregation can compute the aggregated model without exposing any individual update. So if we see this secure aggregation as a black box, it will just take blinded individual updates and outputs the aggregated model, which the server can later use. It shouldn't be possible to reconstruct individual updates from this aggregated result. And it shouldn't also be possible to reconstruct these individual updates if we are part of this secure aggregation protocol. So we shouldn't be able to see individual updates during the aggregation protocol. And techniques such as secure multi-party computation, homomorphic encryption, or even hardware like TEE, trusted execution environment, can be helpful for building this kind of protocols. One of the reasons also the attacks we have seen may be successful is that the model overfits to the training dataset. which means the model will memorize too much information during training. So instead of learning patterns over the data, the model will memorize information about individual input data. So it will memorize like how the image looks like really without learning any pattern. This is already an issue in the machine learning community, which is dealt with techniques such as regularization to have a more generalized model. But the privacy community has also its techniques, and one way to reduce this effect is by using differential privacy during the training process, which by definition will output a model X with approximately the same probability if we train it with or without certain recall, which actually means that an individual picture in our example won't impact the model by that much in order to be distinctive from a model that didn't use that picture during training. So it would be like hard to know that the picture was part of the training. Differential privacy operates by adding some noise at different stage of the training process. And I have pictured that with the colors as the trained model now doesn't remember too much about the data. And so the aggregated model will be also not memorizing a lot of information because of this noise. So far, we have seen both secure aggregation and differential privacy separately, but they can actually be combined together as they offer two different independent functionalities. Now we'll look at the evaluation use case. For our evaluation use case, we are going to use pre-trained models that we actually don't own. So other people have done the training for us and are offering their model either free or as a paid product. So if we wanted to do the evaluation our infrastructure, then we'll need to fetch the trained model from where it's stored, then just perform the evaluation locally. But this might not be possible due to different reasons. One is that we don't have the necessary hardware performance in order to perform that. No one is going to fetch GPT-3 and try to do the evaluation themselves. And so we might use third-party services that need to control our data in order to perform the inference. One other reason is that the model owner may be offering his model as a paid product and doesn't want to hand it using licenses. Instead, he wants to bill users per number of inferences while keeping his model private. So we'll instead ask users to send their data to do the inference. It will be responsible for doing the inference and sending back the result. This also means that the user must now expose his private data to the model owner. So how can we kind of secure this process in order to protect the privacy of the user? We start talking about secure evaluation. Here, we want to protect the user from having his input data exposed in its plain form, and the model owner from having his model exposed as well. So here we talk about both, but some specific use cases may focus only on one, either protecting the model or protecting the input. And in its simplest form, the secure evaluation will start with the client encrypting his input, making it impossible to recover the original data. The client will then send its encrypted input to the model owner for inference, which will respond with the encrypted result. The client can then decrypt the result of the inference. This is a protocol that can be implemented using homomorphic encryption, but other techniques such as SMPC, for example, may be applied, but require different protocols. Mainly more communication rounds will be required. So this is the simplest scenario where we just talk about encryption in the beginning and decryption at the end. But using other techniques may require a more sophisticated protocol that takes more rounds, but the idea will remain the same. We still want to do some kind of encryption at the client level, and so that when we send it to the service provider, he can't just infer the original data, but he can still do the inference for us. So that was like the two main use cases I wanted to focus on without going too much into a lot of use cases. But like more complex use cases can be found in the real world. In our federated learning setting, we just saw that the data is split horizontally, which means that every client will have pictures, so it's not different features, but they will have data about different individuals. However, in real world, sometimes we have some use case where the data is partitioned vertically, which means that different clients can have features about the same individuals. Maybe some might have like some pictures or just x-rays of some patients, or they have some other medical results, but they are all about the same patients or individuals. And we want to want to train machine learning model on that. And it's kind of tricky to do federated learning in this kind of use cases. And of course, as adding privacy to the machine learning process doesn't come to at no cost. Research is really important to advance in the field and lower the cost for adding privacy-preserving techniques. Because as we lower the cost, more adoption rate, we will have more adoption rate, and we can be more compliant, protect users' privacy, and so on. And if you want to look into technologies that help implement privacy-preserving machine learning in more details, crypto is a good point to start, including secure multi-party computation, homomorphic encryption, functional encryption, and differential privacy. And we are just starting this kind of courses around OpenMined. So you may take a look into the courses that will be available. And if you want to just discuss with people around privacy-preserving technologies, so OpenMined is a cool open source community to join and be around. I guess that's it for me. And if you have any questions, you can email or get in touch in Twitter. I guess we'll have actually right now some questions that come from Facebook or something. So over to you.
Well, thank you so much, Mr. Ayoub, for these great informations about privacy and AI. Now let's move to the questions. The first question is, are there any good resources to learn about privacy preserving using machine learning?
So actually, I would say the best resources to the latest advances in privacy preservation learning would come from papers, because it's the field is growing really fast, but other people are writing some blog posts around OpenMined, trying to explain these papers and these techniques. So if you go to Mind's blog, you would find a lot of courses there. There is also an introductory course in Udacity around private AI. And so yeah, as I have said also at the end, there will be a series of courses around privacy preserving technologies anytime soon around OpenMined in the beginning of 2021. I can maybe later compile of resources, and you can post it if you want.
So the next question is, are these methods proven to be fully effective, or are these always ways to invade people's privacies?
He's still online.
I can repeat the question for you. Well, the question is, are these methods proven to be fully effective, or are there always ways to invade people's privacy?
Um, I'm here. I was just waiting for the next question, maybe.
Question is, are these methods proven to be fully effective, or are there always ways to invade people's privacies? Please, please.
Hi again.
Hi, could you hear me?
Yeah.
Yes. So the next question is, are these methods proven to be fully effective, or are there always ways to invade people's privacies?
So I guess we'll need to talk about one of the specific techniques in order to talk about its effectiveness. So there is kind of protocols that have assumptions about how the clients will operate in the protocol and so on. So it really depends on the techniques you are using and its assumption. So there is like kind of, if we talk about homomorphic encryption, it's like there is like security proofs around the encryption and decryptions. So if the protocol is used properly, you wouldn't be able to recover the data. But other protocols, maybe in the SMPC techniques, they may have some assumptions about the clients who computes during the protocol. Maybe they assume that they are honest, for example, and they won't be like they will follow the protocol as agreed in the protocol, but if they try like to recover the data, they shouldn't be able. So it depends on the technique used and its assumption to tell about what it's really protecting. And some of the protocols have security proofs and other doesn't. So if we need like to really talk about specific techniques in order to tell against what it can protect and how effective it is.
Okay, so thank you. I hope that they can benefit from your answer. The last question is, because we are running out of time, what are the obstacles of using federated learning?
Okay, so I would say when you start doing federated learning, one of the main problem would be in the aggregation process. So when you have like this, when you train three different models, the aggregation actually may not have like may not end up in a really good model. So this would be like challenging to train on different data that is kind of have different distributions, and each client will end up with a different, like they diverge in their final model, and the aggregation might be hard. So it's not just like training on like centralized data, it's kind of different. So that's like a challenge around machine learning. And without talking about the privacy implication and the need to use secure aggregation and the engineering challenges around that.
Okay, so thank you so much, Mr. Ayub, for this amazing session. Thank you so much, you guys, for attending the talk. I hope it was benefit for you, and see you in the next talk, supervised by Women Tech Makers Algiers, which is going to be about how to keep your kids safe online. So see you there. Thank you once again, Ayub. And just
Thank you.
guys, don't forget to check our keynote, which will be posted later, inshallah. And goodbye.
Thank you. Goodbye.